So here is a diagram showing main features of our sun. It is much bigger in size compared to the Earth. Its radius is 700,000 kilometers, which is about 109 times the radius of the Earth. The visible surface of the sun that we see is called photosphere, and it's the thinnest part of the sun. It's only 500 kilometers thick. There's also solar atmosphere, which consists of the lower atmosphere, so-called chromosphere, which is about 2,000 kilometers high. And then above it, we have the sun's outer atmosphere, corona, which you can see during, say, a total solar eclipse, or if you block artificially the photosphere of the sun by putting in an obstacle, then you can actually observe the corona. It's very low density, but extremely hot. The surface temperature of the sun is about 6,000 degrees, and the temperature in the corona reaches 1,000,000 degrees. Why is that so? We don't know for sure even to this day. There are guesses, probably good guesses, that it has to do with the sun's magnetic field, that the magnetic field lines get twisted, right? And then when they get twisted too much, they actually untwist with release of a great amount of energy that heats up the sun's outer atmosphere. But we don't know for sure. There are, of course, sunspots on the surface of the sun, which are, as I've mentioned earlier, they are just regions where the sun's surface is less warm than its surrounding. Then when there's a lot of sunspots, when the sun is very, very active, like it is right now, we are now going through the maximum in the solar activity. There are features like these prominences and so on. Here you see the actual photograph of the sun with one huge, huge prominence. Just how big it is, you can estimate by comparing its size to the size of the Earth and the size of the largest planet, Jupiter, which is about 10 times bigger than the Earth. So these eruptions, when the sun is very active, are quite spectacular. They're enormous in size. Then there is interior of the sun, the core, where basically the energy gets produced through the fusion of hydrogen into helium. The temperature of the core right now is 15 million degrees Kelvin. And then that energy produced is transported to the surface via two processes, so-called radiation, and that part of the sun is called the radiation zone. And then closer to the surface, the convection currents take over and transport the energy to the surface of the sun. Okay? So I have given you just a very brief overview of certain general features of the sun, and we'll now go through them in detail. First of all, its radius is 109 times radius of the Earth. And we can determine that by knowing the distance to the sun and measuring its angular size. Then using simple geometry, we can figure out how large the radius of the sun is. A mass is 300,000 times bigger than the mass of the Earth. More specifically, it's about 10 to the 20 kilograms. And again, we find the mass of an object by measuring the orbital data of another object revolving around it that is gravitationally bounded. So from the orbital data of any planet revolving around the sun, we can determine its mass using the third Kepler's law as formulated by Newton. Once you know the radius and the mass, From radius, you can calculate the volume, and then dividing the mass with the volume, you can calculate the average density. Is about 1.4 grams per centimeter cubed. The energy output of the sun can be obtained from its brightness as measured here on Earth, and knowing the distance to the sun, then we can use that brightness luminosity distance relation to figure out what the luminosity is, and it turns out to be 4 times 10 to the 26 watts. Surface temperature is about 6,000 degrees Kelvin. And again, we can determine that, say, using the Wien's law and by analyzing the sun spectrum. As I mentioned before, the visible surface of the sun is called photosphere. Its thickness is only 500 kilometers.